forgot exactly what one side was. We had to confirm the trigger intensity, but I remember the other side was two, either secant or cosecant, two, I think it was cosecant, two cosecant of two theta, and we had to equal it to the other side. And I didn't. I had to think about it.
Maybe the other side was 2/1 sine.
It simplified to 1 over sine.
That side becomes 1 over cosine.
Yeah.
Probably.
That was the only one that I was like, I don't know if I did that correctly, but I feel like there was no other thing for me to do. Like I used the double sine formula, and I made it instead of, I don't know if you're allowed to do this, but I made it 1 over the double sine formula. You know what I mean?
I'm actually not sure whether we're allowed to do that or not. If sine 2 theta is 2 sine cosine,
Yeah.
then cosecant 2 is 1 over 2 sine cosine.
That's what I did because, and then because
let's see what's the formula for cosecant.
There's 2, so it's 2 over 2 sine theta cosine theta, and it's simplified for me, but I was like, what if that's like the trick? Because I personally couldn't imagine a way to do that. I couldn't figure it out. No, don't check right now.
I want to see what's the double angle for cosecant. Double angle for cosecant.
I'm gonna cry. I think it is. He'll understand what I wanted to do, and he'll give me half credit.
Some points will be given. 1 over 2 sine cosine.
I don't know. Did we ever have this?
Yeah, I think it's same. Okay. So cosecant double theta is 1/2 secant, but secant is 1 over cosine, and cosecant is 1 over sine. So basically, 1 over sine and cosine, which is 1 over sine double angle. Yeah, it makes sense.
You need to ask us a week after because we only get our tests back at the end of class. So we have to wait until 5:30. We can make sure to wait until the very end of class. So no one can. I think we might. Yeah. No. Really?
Thank you. So this week we have a fun exercise, a little exercise, not too many questions.
No.
It's about complete the square. Do you remember you complete the square? So all you have to do today is complete the square many times. 6 times. I think we have 6 questions. No, 5 questions. So let's start. These are not questions.
Yeah, but we're gonna see
So yeah, from today's recitation, there will be at least 1 question from the sample in your exam. Like question 3, 4, or 5, there will be at least 1 in the exam. Guarantee. Now, before going over the question, let me tell you, how do you complete the square? Just to refresh your memory. You can complete the square in many ways. That thing I found easier for me or for few students is this. When we have a function y equals, let's start with something that doesn't have leading coefficients. So if we have a function, not equation, function means one side is equal. Okay? An equation means the other side is not equal, either it's a constant or something else. So when you have a function, when you complete the square, it's simple. It's x plus half of b. So whatever we have here, we take half of that. Inside a parenthesis, and we complete the square. We complete the square. We complete the square, but we also have to do something extra. Since we added this amount here, we are gonna always subtract the same amount with the square outside of completed square. So same thing, we do it twice, once with a square, once without a square, because our square is inside outside. And we bring down our constant. So then you combine these, whatever you get, that's your KW. Okay. So that's what you do when you have a function. And then you have two scenarios. Let's see if function has a leading coefficient. Ax squared plus bx plus c. Now, since we have a leading coefficient, first we have to pull out that as a common factor from the x terms. So we get y equals x squared plus b over a x, and then extra c outside. So we only pull out the leading coefficient as a common factor from the x terms. We let the constant alone. We don't care about that. Now we complete the square. Sorry. Yeah, right. So we get x plus b over 2a. And then square outside. So we subtract the same amount, b over 2a with a square, plus the constant c. But since we took this a out as a common factor, so when you put a constant, we have to multiply by the constant, by the coefficient. So you do the same thing, but this time it's a times half of b over a squared. Half of b over a is same as b over 2a. They're the same thing. And then we combine them to get our constant. And it's done. We completed the square. That's the rule. Whatever we have for b in front of x, we take half of it inside the parentheses with the sign, and then we put outside we put the square. And then if it's a function, we subtract the same amount after we complete the square and combine that with the constant. But if you have an equation, ax squared, no, let's start with x squared plus bx plus c equals 0. Now this is not a function, this is an equation. It's an equation because we have equals to a number. It could be 0, or it could be anything else. When it's equal to 0 or equals to a number, it's an equation. So what we do is we take out x, we move c to the other side. So we get x squared plus bx equals negative c. And now we're going to complete the square. So from here, we get x plus b over 2 square. And we are done on this side. And we add the same amount on the other side. What happened to my pen? So if it's a function, you subtract the amount from your square term. But if you're working with an equation, you can add the same amount to both sides. But if you want, you can subtract them after the square. It doesn't matter. It's the same thing. So we complete the square. We are done. And you just combine them. Lastly, if you have a leading coefficient, y equals, so not y. If you have ax squared plus bx plus c equals 0, we pull out a from x squared and you subtract the c from both sides. You can pull out, you can divide both sides by a, so they cancel out. And then you can complete the square here, only the inside. So we get x plus twice of this amount, the square, negative c over a plus b over 2a square. And since we don't have any leading coefficient because we divide both by that, so we don't have to multiply by a. So that's the rule to complete the square. Now this is one of the rules, okay? Now it's not the only rule. It's one of many rules. Now if you learned any other way, no problem, use your method. It's okay with that. Now let's do one of them. Which one you want me to do, one or two? In one, you're solving. In two, you are writing in standard form. Two? Okay. So 2 says y equals 3x squared plus 12x plus 5. So this is a function, not equation. It's a function because we have y in one side. That means we are going to subtract half of b. But we have a leading coefficient. Since we have a leading coefficient, our first job is to take out that as a common factor. So we get y equals 3x squared plus 4x plus the 5. I didn't take out 3 from 5 because 5 is a constant, is useless. We don't need that constant. We only need x squared and x term to complete the square. So we pull the 3 as a common factor from the first two terms. Now to complete the square, we keep our 3, but from here we write x plus half of b. So this is our b, we take half of that. And then it's outside. Now we're going to subtract the same amount, half of 2 is square. But since we have a leading coefficient here, so we need to multiply by that also. So it's 3 times half of b squared. And our useless constant, we bring it down. So we have done complete the square. All you have to do is simplify. So we are going to combine them. We have y equals 3. What is half of 4? 2. So it's simply 2 squared. And then we have 3 times 2 squared, which is 4 plus 5. So 1 plus 2 squared. This is 12. So 12 minus 5, 7. That's the standard form. Standard form of parabola. Now it says write in standard form and then identify the vertex. So before finding the vertex, let me write the general standard form. The general standard y equals a x minus h squared plus k. That's the general format without any number. So from here, we can see that our negative h is 2 and positive k is -7. So vertex is h comma k. So this portion is telling us that negative h is 2, but we are not looking for negative h, you're looking for positive h. So what is h? -2. And this portion is telling us that our k is -7. That means the vertex we have here is -2, -7. So standard form and vertex. This is one way of finding. Another way of finding it would be, use the formula for vertex. Who has a question? Was any step unclear to anyone? Don't be shy. I know many of you are not doing well in your class. So I'm here to help you. You didn't know that? Somehow I know that. And the teacher is very sad for that instructor. Hmm? I didn't see the grade, but
like the test average? Like, does our teacher tell us?
no,
How do you-
secret.
We all did very.
Hmm?
We all did very good.
In which one?
In all.
Really? That's wonderful. So you guys are doing great, but many of you are not doing great. Many of the students in this class are not doing well in lecture. I cannot complain about the recitation because you're doing it all. So it's not a test. Not talking about overall, not this exam, overall. Overall class grade. It doesn't look too good. Is it only me? It's really hot here today.
Our classroom is all 90 degrees.
And so I would get to the basement.
No, it's on the first floor.
And still hot.
It's like those windows face the sun. They're like all around the entire classroom, so it just beams like warm.
Wow.
I fall asleep.
Play with the thingy. I don't see it here. The thermometer we have.
I don't know if we have one in class,
Yeah, I don't see it here. Probably goes.
but it's like I fall asleep.
In hot.
Yeah, it's like I was just like.
Okay, so does anyone have any question on this? Okay. If it looks harder to you, you can use the vertex formula. Vertex formula will be easier to do it, but I'm not going to show you. I'm too lazy. Instead, I'm going to do 1 from the square. So in a square, 1 from circle. So for circle, we have 3, 4, 5. Which one looks harder? From question 3, 4, 5. Any suggestion? 3, 4, 5. 4? Okay. So we have 2x squared plus 2y squared equals 12y. Our problem number 1 of the y is on the other side of the equal sign. So in order to complete the square, we must bring x terms and y terms together. So we get rid of the 12y from both sides. So we get 2x squared plus 0. So first problem solved. Now we face second problem. Our second problem is x squared and y squared, they have some number in front of them. But in order to complete the square, we don't want any number in front of x squared and y squared. Luckily, we have the same number. So how can we get rid of that number?
Divide.
Just divide. So we're going to divide everything by 2. We get x squared plus y squared minus 6y equals 0. We're kind of happy, but also we are sad at the same time. Y squared has a friend, negative 6y. But x squared doesn't have a friend. Now let me tell you the format. Standard format of circle. Standard format of circle is like very similar to parabola. X minus h inside, outside of a square, then plus always y minus k inside, outside of the square, and our constant is called r square. So in here, our center is the opposite sign from the inside, hk. Inside you have a minus for both h and k. So when you take them as a square, as a center, we take the opposite sign. And from here, our radius is square root of the constant, which is r. So our goal is to rewrite what we have into that format. X minus something squared plus y minus something squared equals a number. Now, x doesn't have any friends. So how can you write this as x minus something squared? How can you write x squared as x minus something squared? X minus 0 squared. See, adding a 0 or subtracting a 0 doesn't make any difference. So x squared is x minus 0 squared. So you're happy. We didn't have to complete the square here. We got the first part automatically. Then you have a plus sign. And now you have to complete the square for y. So the format is y minus half of the number you have in front of y. Half of 6, right? In front of y, not y square. So whatever we have here, including the sign, we take half of it. And then we square it. That's the complete square. Always, whatever we have in front of you, x term or y term, we take half of it and then we square it. Equals 0. Now, since it's an equation, we have to add the same amount on the other side. Plus half of 6 squared. In an equation, if we add whatever you are adding inside, you're going to add the same amount with the square on the other side of the equation. So you're done. We complete the square. We have x minus 0 squared, y minus 3 squared equals 0 plus half of 6. What is half of 6? 3. So we have 3 squared. That's the standard format they're looking for. Now we just have to give them center. What's the center of the circle? 0 and 3. 0 from here and 3 from there. And radius. It's square root of 3 squared, which is 3. So they are asking for the center and and radius. Three things: the standard form of the circle, what's the center of the circle, and what's the radius of the circle. And guess what? This will be in the exam. So I give you one of the questions from the exam. You don't have to, but let me show you the graph. We have a center 0, 3. So 1, 2, 3. This is our 3. Actually, let me draw it a little bit to the left. We don't have enough space. 1, 2, 3. This is our center 0, 3. From this center, we are moving 3 units up, down, left, right. So 3 units left is here. 1, 2, 3. Right is here. 1, 2, 3. Up is here. 1, 2, 3. Down is here. So you go 3 units each direction, and then you draw a circle. So that's the circle, equation of the circle given to us in a weird way. But you're so smart, we converted the weird formula into standard format, and then we figured out what's the center, what's the radius, and we could draw the graph easily. Any question? Okay, then we're done with this. Don't leave, complete this and give it to me today, because these are fun and easy. And I'll go around to help you. So you're gonna do question 1, 3, and 5. For 5, your hint is divide everything by 3, because you want x squared and y squared alone, without any number. Let me pause it.